And this is the Chapter 16 chapter review. So number 1, we're supposed to write these products using exponents. Well, -9 in parentheses, of course, because we want it to be a -9. 1, 2, 3, 4, 5 times, multiplied together, using itself as a factor 5 times, is -9 to the 5th power. Number 2, we've got 2 times 2 times 2, which is 2 to the 3rd power, times, and then we have n times n, which is n squared. Now that multiplication isn't really needed, so this could also be 2 to the 3rd power, n squared, just like that. Number 3, evaluate the expression. So now this is 6 to the 3rd power, which means 6 times 6 times 6, and 6 times 6 is 36, times 6 is 216. Number 4, we have negative, and that's outside the parentheses, 1/2 to the 4th power. So each of these things to the 4th power would be, so the negative stays out front, 1 times 1 times 1 times 1 is 1. And 2 times 2 is 4, times 2 is 8, times 2 is 16. So -1/16. Had this negative been inside the parentheses, this would have been a positive 1/16. But it wasn't, so it's not. Number 5. We've got the absolute value of 1/2 times 16 minus 6 to the 3rd power. Well, we know 6 to the 3rd power from a previous problem is 216. So now we have the absolute value of 1/2 times 16 minus 216. 16 minus 216 is going to be -200. So now we have the absolute value of 1/2 times -200. Well, half of -200 is -100. And the absolute value of -100 is 100. So for the next problems, it says simplify the expression. So it says p to the 5th times p to the 2nd. And remember, when we're multiplying same bases, then we just add their powers. So this would just be p to the 7th, number 7. N to the 11th to the 2nd power. When we're raising a power to a power, we multiply those powers, giving us n to the 22nd power. For number 8, 5y in parentheses to the 3rd power. Well, now that 3rd power applies to each thing inside. So this is 5 to the 3rd power, y to the 3rd power. And 5 times 5 is 25, times 5 is 125. So this is 125y to the 3rd power. And number 9, in parentheses, -2k to the 4th power. -2 times -2 is +4, times -2 is -8, times -2 is +16. So this is going to equal 16k to the 4th power. The next set of problems say simplify. So for number 10, we've got 8 to the 8th over 8 to the 3rd. 8 to the 8th over 8 to the 3rd. Well, we subtract when we're dividing same bases. We subtract their powers. So this would equal 8 to the 5th power. No, and it says write your answer as a power, so we won't evaluate that. We'll just leave it 8 to the 5th power. Number 11, we have 5 to the 2nd power times 5 to the 9th power over 5, which is 5 to the 1st power, but we don't have to put that. Let's do this up here first. 5 to the 2nd times 5 to the 9th equals 5 to the 11th power over 5 to the 1st power, which is going to equal 5 to the 10th power. Number 12, well, these go pretty fast, w to the 8th power over w to the 7th power, all times w to the 5th power over w to the 2nd power. Well, w to the 8th over w to the 7th gives us just w, or w to the 1st, and then w to the 5th over w to the 2nd equals w to the 3rd. Now we can multiply these two by adding their exponents and get w to the 4th power. Number 13. On number 13, we have 2 to the 2nd power times 2 to the 5th power all over 2 to the 3rd power. Well, on top, we will get 2 to the 7th over 2 to the 3rd, and now we'll get 2 to the 4th. And this does say simplify the expression, so we will do 2 to the 4th. 2 times 2 times 2 times 2 equals 16. And number 14, 6c in parentheses to the 3rd power over c. 6 times 6 times 6 is 216, c3 over c. And now we can simplify right here, giving us 216 c to the 2nd power. Number 15. We have m to the 8th over m to the 6th, all times m to the 10th over m to the 9th. This is going to be m to the 2nd times m to the 1st, which equals m. That's supposed to be a times. Put it up there. To the 3rd. M to the 3rd. Number 16. For 16 through 21, evaluate the expression. So for number 16, we have 2 to the negative 4th. Well, remember that negative 4th means that this is on the wrong side of the fraction bar. So we will put it underneath 2 to the 4th. That's better. Now we have a positive exponent, and 2 to the 4th is 16, so we have 1/16. For number 17, 95, I'm going to do number, who cares? 95 to the 0 power, anything to the 0 power is 1. Number 18. For number 18, we have 8 to the 2nd power over 8 to the 4th power, which is going to give us 1 over 8 squared, or 8 to the 2nd power, which would be 1 over 64, 1/64. Number 19, we have negative 12 to the negative 7th power times negative 12 to the 7th power. Or multiplying these, so we add their exponents. That would give us negative 12 to the 0th power, and anything to the 0 power is 1. Number 20. 1 over 7 to the 9th times 1 over 7 to the negative 6th power. Well, a couple of different ways we could do that. We could just add these two and get 1 over 7 to the 3rd power. Not a horrible way to do that, but I like to keep the exponents positive, and I would turn this into 7 to the 6th over 1. Now I would get 7 to the 6th over 7 to the 9th, and now 1 over 7 to the 3rd. My way took a little longer, but I like it, so that's what I do. And 7 times 7 is 49, times 7 is 343. So 1 over 343. Number 21. We have 9 to the 4th power times 9 to the negative 2nd power over 9 to the 2nd power. Well, if we take this 9 to the 2nd power where it belongs underneath and join it here, we would have 9 to the 4th over 9 to the 4th. which is 9 to the 0, which is 1. Excellent. For 22 through 27, write the number in standard form. So they're giving it to us in scientific notation, and we are unscientific notationing it. That is not a real phrase, but I made it up and I like it. So 2 times 10 to the 7th, 2 times 10 to the 7th equals, we have to move the multiply by 10 7 times. So 2, 1, 2, 3, 4, 5, 6, 7. Doing, doing, 20 million, of course. For number 23, 3.4 times 10 to the negative 2. So we'll move it back 2 places, giving us 0.034. For number 24, it was 1.5 times 10 to the negative 9. So we have to move it back. The first move is going to just take care of this 1 and then 8 zeros. So 0.000000015. Number 25, 5.9, 10 to the 10th. 5.9 times 10 to the 10th. The first move is that move right there, getting on the, and then 9 more moves, so 9 zeros, so 5, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, comma, 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 59 billion 26. 4.8 times 10 to the negative 3 equals 3 moves this way, so 0.0048. And 27. 6.25 times 10 to the 5th. 2 moves to get on the other side of those numbers, so only 3 more. So 3 zeros there. 625,000. Excellent. The next 3, 28 through 30, we have to write the number in scientific notation. So for number 28, the number was 0.00036, and that's going to equal 3.6 times 10 to the 1, 2, 3, 4, negative 4th power. For number 29, 800,000 equals 8 times 10 to the 1, 2, 3, 4, 5. Oops. 5th power with a little line that means nothing. Very good. 30, 79,200,000 equals 7.92 times 10. 1, 2, 3, 4, 5, 6, 7 to the 7th power. And then the last 4 problems where you're adding, subtracting, multiplying, and dividing. Some numbers that are in scientific notation. And we have 4.2 times 10 to the 8th plus 5.9 times 10 to the 9th. Well, the first thing we have to do is put these into the same power of 10. So, if I make this bigger, that gets smaller. No, if I make this bigger, that gets smaller. That'll work. So we'll keep this one the same. 4.2 times 10 to the 8th. And I'll make this 59. So I made it bigger by 1 power of 10. I make this smaller by 1 power of 10. Yay, and now they're the same. So I have 4.2 plus 59. I'll put a 0.0 there. It's easier to line up my decimals. 63.2. 63.2 times 10 to the 8th. Not quite scientific notation yet, but that's an easy fix. 6.32. I made this smaller, so I make this bigger, times 10 to the 9th. Number 32. 5.9 times 10 to the negative 4th power minus 1.8. Wow, that was supposed to be an 8, and it turned out to be like a scribble. Times 10 to the negative 4th. Nice, they're already in the same power of 10 here. So we just subtract 5.9 minus 1.8 equals 4.1. Oh, it's working out almost too easy. Times 10 to the negative fourth. It's already in scientific notation because there was just one spot behind the decimal, or in front of the decimal there. And then 33 and 34, a multiply and divide. We have 7.7 times 10 to the 8th times 4.9 times 10 to the negative 5th. So we'll multiply 7.7 and 4.9. 7.7 times 4.9 equals 37.73 times 10 to the, and remember we are just going to add these to get 10 to the third. Not scientific notation yet. A move here. Make this smaller. So make this larger. 3.773 times 10 to the fourth power. And finally, number 34, we have 3.6 times 10 to the fifth divided by 1.8 times 10 to the ninth. So 3.6 divided by 1.8. So 3.6 divided by 1.8, move and a move. So 36 divided by 18 equals 2, which is 36, which is nice. And then I've got 10 to the 5th divided by 10 to the 9th, which is going to give me 10 to the negative 4th, because 10 to the 5th divided by 10 to the 9th, we've got more down here on bottom, so we'd have the 10 to the 4th down here, and if it's down here, then when we move it up, it would be a negative 4, because we moved it on the other side. So 2 times 10 to the negative 4th power, which is in scientific notation. Excellent. Well, if you understand all those, you are ready for the test. So go do so. I mean, go take it. I mean, you know what I mean. Take the test. Do well. Good luck.